Okay, so let's talk a little bit about the advantages of binary or digital, right? Digital, binary meaning digital storage, right? If we store something as analog, right? Let's say it's a song or something like that, right? The signal is like this complex thing. When it degrades, right, it's not going to sound quite as good, right? Digital storage, we take that information and we store it as either it's on or it's off, right? Bits are like totally, the medium is totally saturated. If it's like a magnetic tape, we totally saturate it north or we totally saturate it south, right? Okay. Right now, if we degrade an analog thing, right? If we talk about the degradation of this over time, temperature and just the Earth's magnetic field and just the aging of the material makes this thing, and basically this thing it wears down all the bumps, right? So this thing becomes something that's less than it, right? This is very hard, and basically there's noise superimposed on top of this, right? It becomes very hard to figure out what the original signal is based on the degraded version of the analog, right? But if we take a digital signal and we degrade it, right? It's like, here's a degraded digital signal, right? It's just these bumps, and I'm drawing them sharp, right? They're probably just rounded like this, right? Well, gee, even if we round off those beautiful square things that it once was, it's easy to tell that that was a bit and that was not a bit, right? We can still go through and there's going to be some faint trace of it, right? Okay, so this is the notion, is that even if we degrade a digital signal, since the signal itself was so polarized, so either totally north or totally south, we can still sense a little bit of that, right? Okay, so when a digital signal degrades, it still is recognizable because it either was on or off. We don't have to guess, was it 10.5 or 10.6, right? It's just 10 or 0 or 10 or 0, right? Okay, so the other cool thing is that if you copy a CD, right? If you copy a tape, it's got to go through some electronics, right? And when it comes back, it's not quite as good as it was because the electronics add noise. When you copy a CD, and this is of course what the music industry realized, right, was that the copy is as good as the original. It's an exact duplicate, right? Computers do that because if you lose a bit anywhere, your computer program doesn't run. Okay. The other thing that's kind of cool is that that CDs, especially DVDs, okay, and I'm sure Blu-rays as well, right, have these error correction schemes in them where they store the information redundantly. And if there ever is a read error, there are ways to actually correct that and sort of get back on your feet. And yeah, okay. The simplest thing, a way of detecting an error, is that you just simply add up all the bits in a sector and say, okay, everything in this sector adds up to 37. And if it ever doesn't add up to 37, then something was dropped somewhere in the middle. That's called a checksum. But there's far more sophisticated algorithms, especially on DVDs, I'm not going to do that anyway. So yeah, very cool.